بسم الله الرحمن الرحيم. Today inshallah we are going to talk about electrochemistry. Firstly, the concept that we are going to talk about dim oxidation, chapter 18 in Zomdel, oxidation number. Oxidation reduction, electron transfer, then talking about the electrolysis. Firstly, when we return to your feedback in the preparatory stage, you will find it talking about the thing it's called the valency. What's meant by the valency? Valency represents number of electrons which atom lose, gain, even share during the chemical reaction. Let's talk about the two simple examples like sodium 1123, positive 11, positive negative 12, 281 KLM. During the chemical reaction, come in, it will lose an electron. So we'll find the sodium lose an electron during the reaction, change into Na positive. In this time we'll find positive 11, positive negative 12, 2 and 8, K and L. So in this time we'll find the sodium lose one electron, and it is the monovalent. And when we look to chlorine, and when we are going to talk about the chlorine, we'll find the chlorine positive 17 and positive negative 18. So it will be 2, 8, 7 K L M. In this case we will find it the gain 1, gain an electron. And we'll find the chlorine in this case, it will be Cl negative 1, positive 17, positive negative 18, 288. So in this case it's called the monovalent, else. So the valency in this case returns back to the number of electrons which atom lose or gain during the chemical reactions. We can consider the valency now represented the thing it's called the oxidation number. So oxidation number, it is else, the number of electrons which atom lose, gain, even share during the chemical reaction, it's called the oxidation number. So if we classify the element, we are going to classify the element according to the valency. Elements, it will be mono, dia, tria. Monovalent, it will be maybe positive 1 or negative 1. Divalent, positive 2 or negative 2. Trivalent, positive 3 or negative 3. Group 1A, lithium, sodium, potassium, rubidium, cesium. They are in the group 1A and they are positive 1. I know, but we are making the recording for you, okay? Then we'll find hydrogen, and else we'll find the silver. Silver from transition element, and the hydrogen, it found in the group 1A, it's only in the position. But when we are going to talk about the monovalent nonmetal, group 7A or group 17, fluorine, chlorine, bromine, iodine, and acetine. Acetine is prepared artificially in the lab, so it will not take in our consideration. Divalent, we will find the group 2A, beryllium, magnesium, calcium, strontium, and barium. Add to them transition elements like the zinc, tin, lead, iron and lead. We'll find the mercury, copper. They are from transition element. Sometimes we'll find divalent element. We'll find the oxygen and the sulfur. Trivalent, we are going to talk about the aluminum, gold, chromium. Negative 3, we are going to talk about nitrogen and phosphorus. Let's talking about the elements that have more than one oxidation state. More than one oxidation state, we will find the sulfur. More than one oxidation state. We'll find the sulfur, maybe dia, tetra, or hexa. We'll find the iron, positive 2, and iron, positive 3, ferrous, and ferric. Sometimes we'll find the copper, positive 1, and copper, positive 2. If we are going to talk about the transition element, oxidation number not exceed group number like 3D first transition series from the main transition element, not inner. So we'll find it not exceed the group number. Like if we take an example, the chromium CR18, CR24, AR18, 4s2, 3D, 4. For the electronic exception, we'll find that taking one electron, and it will be the 5. It's not our topic, but we are going to talk to determine the group and period. It will be in the period 4, but in the group we will sum the electrons at the S and the T. But we'll find the form, it will be NS and N subtract 1 D. So in this case we will find the electron days are 4, or the electron days are now 1 plus 5 electron in the D, it will be 6. So it will be in the group 6p. Okay? Not to exceed the group number, so we'll find the higher oxidation state for the chromium in its compound, it will not exceed positive 6. N represent the quantum number, so it's N equal 4. Then 3D, 4s is 3D. So 4 subtract 1, it will be 3. So in this case, if we represent 4s, then 4 subtract 1, D, it will be 3D. 4s, 3D. But we will find exception in the first transition series for the copper. We will find the copper in the electronic configuration 29, so it will be AR18, 4s2, 3d9 with electronic exception, it will be 1 and 10. It was 9. So it will be in the group 11. Group 11, it means 1b. So the mass oxidation number not exceeded 1, but we will find for the copper oxidation number may be positive 1 and positive 2. And the positive 2 is the common. Okay? Group 5A. We'll find the group of the 5A, it's the mixture. Group 5A, it will be nitrogen, phosphorus, arsenic, antimony, and bismuth. Non-metal, metalloid, and metal. But it is one from the weakest metals. The bismuth is one from the weakest metal. For the nitrogen and phosphorus, we'll find that the oxidation number are varies from -3 toward the positive 5. Let's take an example. In H3, N2H4, H2OH, N2, NO2, N2O3, N2O4, N2O5. N2O2. If we calculating the oxidation number for the nitrogen in this compound, we'll find X plus 3 multiply positive 1, it will be equal 0. So the X equal -3. 2X plus 4 multiply positive 1 equal 0. 2X equal -4. X equal -2. X plus 3 multiply positive 1 for the hydrogen, since when having a 3 hydrogen atom, plus -2. X equal 0, so the X equal -1. In elementary state, nitrogen, oxygen, fluorine, hydrogen, chlorine, bromine, iodine, they all equal oxidation number equal 0. So X in this case, 2X equal 0, X equal 0. 2X plus 2 multiplied -2 equal 0. So 2X equal 4, X equal positive 2. 2X plus 3 multiplied -2 equal 0. 2X equal 6, X equal positive 3. 2X plus 4 multiply -2 equal 0. 2X equal 8, X equal positive 4. 2X plus 5 multiply -2 equal 0. 2X equal 10, X equal positive 5. So we'll find it derived from starting -3 till it reaches the positive 5. Let's talking about the exception for the hydrogen. The most common state for the hydrogen positive 1, except metal hydrides equal -1, like sodium hydride, calcium hydride. X plus positive 1 equal 0, X equal -1. X plus 2 multiply positive 1 equal 0, X in this case when having only the calcium, not correct. 2X plus 2 equal 0 for the calcium. دي كان نص عملكم.
هو ليه الكالسيوم الاثنين؟
So the calcium, the 2x represented for the hydrogen, 2x. And the calcium, its valency positive 2 equal 0. So the 2x equal negative 2, x equal negative 1. And for the oxygen, the common for the oxygen, negative 2. But peroxide, superoxide, fluoroxide, so the peroxide, it will be like H2O2, superoxide KO2, fluoroxide OF2. In this case, we're calculating the oxidation number of oxygen. 2 multiply positive 1 plus 2x equal 0, 2x equal 2, x equal 2x equal negative 2. So the x equal negative 1. Potassium superoxide is called the chemical plant since it's used in the closed submarines and the aeroplanes in filters to replace the carbon dioxide gas out from respiration by the oxygen gas. It's absorbing the carbon dioxide gas and obtain from it or giving to us oxygen gas. Used to respirations in the filter of the air conditioners in the closed submarines like the submarines or the aeroplane. So the potassium, positive 1 plus 2x equal 0, 2x equal negative 1, x equal negative half. If we're returning to the values of electronegativity, we'll find the sodium equal 0.9, hydrogen equal 2.1, oxygen equal 3.5, nitrogen and chlorine equal 3, fluorine equal 4. So the highest one in electronegativity, fluorine. In this case, we will find oxygen x plus 2 multiplied negative 1 for fluorine equal 0. So the x equal positive 2. It is, I'm saying it is the oxidation states for the common or most of the element. If we return back to the concept, it's called the oxidation reduction, redox. If we're making a summary for oxidation reduction, so we're going to talk about oxidation reduction according to oxygen, hydrogen, electron, positive charge. Oxidation, it means increase oxygen and the positive charge, losing electron and losing hydrogen. Reduction, it means lose oxygen, gain hydrogen, gain electron, decrease the positive charge. Sometimes if we return back to the examples that you know, CuO plus H2 by the effect of the heat giving to us Cu plus H2O. In this time we'll find the Cu to Cu, H2 to H2O. There is no oxygen, we find the oxygen, and when without it will without oxygen, so it will be reduction. And we can call the copper oxide as oxidizing agent. In this case, losing the oxygen, reduction, and it will be oxidizing agent. In this case, we'll find oxidation and the hydrogen reducing agent. But if we are going to talk about the transferring electrons, like the sodium react with the chlorine, it will be NaCl. In this time, we'll find Na, neutral atom, change into Na positive 1. And the Cl2 change into 2Cl. For the balancing, it will be the 2Na, it will be the 2Na ions, and Cl2, it will be 2Cl. 0, negative 1. In such time, we'll find increase the positive charge, it means lose electron. Losing electrons, it will oxidation. And the sodium is a reducing agent. Reducing agent. For chlorine, if the change into negative 1 gain electron, it will be reduction and it will be oxidizing agent. The last thing I will told you, what's it about increasing the positive charge? Sometimes we will find for the reaction K2Cr2O7, it's enter the reaction giving to us CrCl3. CrCl3. I want to calculate the oxidation number for the chromium. In this case, it will be 2 multiply positive 1 plus 2x plus 7 multiply negative 2 equals 0. 2 plus 2x subtract 14 equals 0. 2x equal 14 subtract 2 x. 2x equal 12, x equal positive 6. But in this case, x plus 3 multiply negative 1 equals 0, x equal negative 3, or positive 3, I'm sorry, positive 3. In this time we'll find from positive 6 toward negative 3, it decreasing for the positive charge, so it is a reduction process. Reduction process. Okay, inshallah, next time we are going to talk about the electrolysis and complete our lesson. See you soon, inshallah.